Let's look first at the modeler application. The modeler is really the heart of the Maxsurf system, and as I mentioned, it uses 3D NURB surface modeling, non-uniform rational B-splines. But not only does it use that approach in modeling, it contains a couple of special capabilities, particularly relating to surface trimming, where we have a situation where we have complex edges on a surface but a smooth interior. And that trimming is dynamic to allow us to interactively update the model as we modify the design. I mentioned the intuitive graphical interface that's shared across all the applications. That starts in the modeling phase. And of course, it's common to want to work from an existing design as a starting point for future design work, and particularly in the educational context where we'd like to give students a starting point and then perhaps have them adapt that design to meet some slightly different purpose. We have a lot of tools in the modeler to support bringing in offsets tables, bringing in DXF files, bringing in existing NURB models via IGES, or even bringing in scanned background drawings. Part of naval architecture is creating a nice, fair and smooth hull form, and so we have a broad range of hull fairing tools to support creating high quality hull surfaces. And then, as well as working intuitively and interactively, we also have a range of commands to allow the user to numerically modify the design to match certain requirements. So that could be rescaling the design to meet a certain length, beam or draft requirement, or even doing a parametric transformation to move the longitudinal center of buoyancy. And because so many people are using Rhino in a marine context these days, we also offer round-trip import and export with Rhino files. So let's switch over to the modeler application and take a look at it in action. So here we see a 3D NURB surface model of a workboat, and if I just rotate that around, we can see that this model is made up of a number of different NURB surfaces. So we have surfaces for the bulwark, the top side, the bilge area, the bottom of the hull, and even surfaces for the side of the keel and so on. If I go into a profile view, we can zoom in on the front of the vessel, and if I unlock my design, we can see the control points that control the shape of the NURB surfaces. And I'll hide the interior net and we'll zoom in a little further, and here we can see how we can pick up the front of the design and change the shape of the bulbous bow by interactively dragging the points around. If I turn on the buttock lines, we can see how they can interactively be updated as well. The unique trimming that I talked about allows us to trim a hole in the hull here for a bow thruster, and not only is that trimming interactive, it updates dynamically. So if I want to move that bow thruster around, I can just select the control points, pick it up, and you can see that the points will automatically be retrimmed to match the rest of the hull. I'll just lock my hull surface just to leave my bow thruster the only unlocked surface, and then I can move it around like so. If I go to a plan view and I display my water lines, I can zoom in on my plan view here, and again we'll be able to see if I unlock my hull, then we'll be able to interactively reshape the model. You can see the water lines changing as I interactively move my points around. You might see some slight beveling in the curves there. I can change my precision to work at a higher precision so that those curves become smoother. As I select a curve here, I can display the curvature along that curve, and I'll hide everything except the hull. And now when I move my control points around, you can see the curvature lines update automatically to show the change of curvature as I modify my model. So this provides very smooth and accurate control over surface curvature. If I move to a 3D view, I can see here my shaded view, and I can perform different kinds of shading. So I can change my shading to show Gaussian curvature, which is a measure of the curvature in both directions of the surface. And my model is still 3D and interactive at this point. So if I select a particular surface and unlock that surface, and show the control points. Then as I pick up a control point and modify that surface, we can see the very sensitive calculation of curvature which occurs as I change the shape of the surface and it changes from convex to concave, for example. Notice also the property sheet down here, which allows me to have numerical control over my shape as well as interactive graphical control. While we're working, if I go back to a profile view and I turn off my net, then we may want to check some basic properties. If I want to check my hydrostatics, I can choose Calculate Hydrostatics and see all of the key properties of the vessel. So here we see our displacement, our prismatic coefficient, our longitudinal center of buoyancy, and so forth. While we're working, we can also take a look at the curve of areas, and we can see some surfaces missing here, so I'll bring them back so that we can check the shape of our hull form. Finally, we can bring all of this together to create the total design, and that gives us a model here where we have used a wide range of surfaces to define the model. We've used some trimming to trim away a step in the shear line. We've trimmed a hole for the bow thruster, and we've trimmed the keel off to the hull. So this provides the starting point for the rest of the modules, and we'll walk through each of them in turn to see how they can be used for the analysis part of our design work.